Now let's look at acids. Acids are substances that ionize in water to form hydrogen ions. Next, we're going to ask about what does it mean to be a strong acid. The strong part of it means that it ionizes completely. 100% of it turns into ions. There are 6 strong acids that you need to memorize. No way around it, you must memorize these. The first 3 are HCl, HBr, and HI. These are halogens except for fluoride. Just remember, if you have an F, you're weak. The next 3 are hydrogen sulfate, hydrogen nitrate, and hydrogen perchlorate. You need to be especially mindful of the number of oxygens on each of these substances. It is always the one with the highest number of oxygens. Now we're going to focus on some calculations. We're going to move letter C down because I don't want to focus on it yet, and we're going to give an example where we're going to try 100 particles of HCl. In this example, we're going to look at what it looked like before and after it reacted. If we have 100 particles of HCl and we have no H plus or Cl minus before the reaction, what do you have afterwards? Well, afterwards you have no HCl left because 100 reacted, and we have all of it turning into H plus and Cl minus. Notice that these two are the same number, and they are the same number as what we originally started with here. We know this because we get 1 hydrogen atom for every one anion, and that all came from 1 acid molecule. What if we had started with 40 molecules instead of 100? That means that we have 40 particles of HCl to start with, and we have no hydrogen and no chloride. So what do we have afterwards? Well, if 100% reacts, we have no HCl left afterwards. All of it is turned into H plus and Cl minus, which will now be the same number we started with, which is 40. Now we can go back to our original example of 1 liter of 0.1 molar HCl solution. Let's see how we solve for the hydrogen ion concentration. When we are solving these types of questions, there are 2 things you must look at. First, the first one is whether this is an acid, a base, or a neutral compound. Throughout this section, I will be notating that as ABN. The second step is to identify whether the given compound is strong or weak as an acid or base. So let's look at our question. We have 0.1 molar HCl. Step 1, is this an acid, base, or neutral? Hopefully you could identify this as an acid. Because it's an acid, that means it tells us the hydrogen ion directly. So we see here that it's going to tell us the theoretical hydrogen ion concentration. Now we look at part 2. Is this a strong acid or a weak acid? This one is strong, so that means that we will know exactly the number of the theoretical hydrogen ion concentration. So now let's put that in our chart. How much do I have to start with? I have 0.1 molar HCl. How much H plus? I don't have any. How much Cl minus? Again, I don't have any. After the reaction, after the ionization reaction, I will have 0 HCl left, and I will have, in this case, 0.1 molar H plus and 0.1 molar Cl minus. The only one that I really care about is the H plus because that's what the acid is. We're being asked what is the molar concentration of this strong acid, and the H plus will be 0.1 molar. We normally write that in exponential form, which would be 1 times 10 to the negative 1, or in this case, just 10 to the negative 1 molar. Now, let's find the hydroxide ion concentration. Recall that in aqueous solutions, hydrogen times hydroxide is equal to 10 to the negative 14. When we solve for hydroxide, we divide both sides by the hydrogen ion concentration, and we find that the hydroxide is going to be 10 to the negative 14 divided by the hydrogen ion concentration. That means in our example, the hydroxide ion concentration is equal to 10 to the negative 14 divided by the hydrogen ion concentration, which is 10 to the negative 1. And in our case, hydroxide ion concentration is equal to then 10 to the negative 13.